If you remember from a previous lesson, we've discussed sequences. We've discussed arithmetic sequences where you add a common difference between each term, and geometric sequences where you multiply a ratio. And just as a review, the ratio is R equals T2 divided by T1. Now to find a specific term in a geometric sequence, we'll have Tn, the nth term, equal to the first term times the ratio times n minus 1. Now, if you remember from PEMDAS, order of operations, you cannot multiply the first term of the ratio and then raise it to the power. You're going to raise r to the n minus 1 power first, then multiply by T1. Okay, we're going to use that formula to find the nth term. And just as a reminder, the nth term is T1 times r to the n minus 1. So let's look at our example. We have alternating signs, and an arithmetic sequence cannot have alternating signs. So your ratio is negative 12 divided by 3, so that's negative 4. Your first term is 3, and n is in because we're just finding a general formula. So we're going to begin by substituting in our first term, and then substituting in our ratio, and then that's it. We're done. You do not multiply 3 and negative 4. Now let's look at example 2. If you see our sequence is descending, that means our ratio is very likely a fraction. And we will divide our second term by our first term, and this reduces to 2/3. And 81, that's T1. So let's substitute in. I'm going to put in 81, put in our ratio. Do not multiply those. And that is our formula. Now example 3, we want to find the specified term. So we're looking for a specific position. So when you have something like that, that little number is n. So T12 is our first term times our ratio. And if you look at those numbers, you see you're multiplying by 2 each time. And it's going to be raised to the n minus 1. So do not multiply 5 and 2. Raise 2 to the 11th power first. And this is 2048, and then multiply by 5, which gives you 10,240. Now for the next one, we're actually going to find T1. And we're going to use a system of equations to do this by using T2 and T4 separately. So let's start with the T2. T2 equal to T1 times r to the n minus 1. Well, n is 2. So let's substitute. 8 equals T1 times r. And since n is 2 and minus 1 is 1, so we don't need an exponent here. And let's do the same thing for T4. Now T4 is going to be T1 times the ratio, and 4 minus 1, so that's cubed, so I'm going to write that, and then we'll substitute like so. Alright, what I see is I need to solve for T1. So my first equation, I'm going to divide both sides by T1 and solve for r. And then I'm going to take this entire fraction and substitute it right there. So I'll have 72 equals T1 times 8 over T1, the whole thing cubed. And then what I want to do is distribute that power. And that gives me 5/12 divided by T1 cubed, like that. And so if this were an x right here and a x cubed right there, we would cancel 1x each. So we're going to do that, except with T1. And those cancel. So I'm going to multiply both sides by T1 and bring this over. T1 squared, actually. So I'll have T1 squared times 72 equals 5/12. Well, I'm going to divide both sides by 72. And then I'm going to reduce this fraction. And when I reduce the fraction, it reduces to 64/9, which is very nice because when we take the square root, you end up with 8/3 as your first term. Last examples, we're going to tell whether each sequence is arithmetic or geometric. And the way we can do this is by checking the differences. So if we subtract right here, what we have to add from 8 to get to 15 is 7. And here we're going to add the same thing. Arithmetic means add. So that means we have a difference of 7 and that this is an arithmetic sequence. So we're going to find the nth term. So we'll start with Tn. First term, our difference of 7 times n minus 1. And we don't want to leave our equation like this. We want to distribute the 7. And then combine terms. Like that. Now, example 6. Let's look at this one. To get from 27 to negative 18, we're doing a lot of subtracting. We're going way negative, so I think it's something like 39 we're doing, and that's a negative, and then here we're going to add 30. So this is definitely not an arithmetic sequence, and part of the reason, if you see the alternating signs right here and right here, that can't be arithmetic. So this one is going to be geometric. So let's find our ratio. So negative 18 divided by 27. Those are both divisible by 9, so negative 2/3 is your ratio. And then for our nth term, we begin with our first term, 27, and we're going to substitute in our ratio, 2/3, and then have n minus 1. Now, what you are not going to do not multiply here. And I know it's tempting, but don't do it. And that ends our lesson.